Okay, we're going to take a look at selected problems off of the 8.6 radical equation guided notes. All right, so with 8.6, this is very different from the previous 5 sections. In this section, we're actually looking at equations that involve radicals. We'll have done some of this in class, so I'm just going through and doing selected problems with you here. All right, so the basic idea is that you're going to need to do something to get rid of the radical, and the steps involved, I think, make good sense. So you get the radical on a side by itself if it's not already, and then you raise each side to the power of the index. So if it's a square root, you'll square each side. If it's a cube root, you cube root. If it's a cube root, you cube each side. So you do that to try to undo whatever's been done to the variable. All right, and then you'll get an equation. Sometimes the equation will be linear, but it could be quadratic, and you solve it using whatever technique is necessary. Sometimes there's complicated ones where you have more than one radical, so you have a lot of extra work to do. And then the big thing that happens a lot is this step 4, where you have to check the solutions, because even though you did everything correct, when you square both sides or raise both sides to the 4th power, the solutions that you get aren't necessarily solutions to the original problem. You may get these things, they call them extraneous solutions. So you always have to just check your answers. So you really only have to do that for square roots and 4th roots. But if you're not sure, just check your answers. All right, so let's go ahead and take a look at a problem like number 4. All right, so on that one, I see a square root there, but it has that -4. So the first thing I'm going to do is add 4 to both sides. Okay, so I want to add 4 to both sides to try to get the radical by itself. After I do that, I look at how it's a square root, and so to undo that, I'm going to square both sides. So let me get a different color here. I want it to be red. Okay, so I'm going to come in, I'm going to square both sides. And when I do that, the squaring and the square root basically undo each other, and I'm left with whatever's under the radical, which is 2x plus 3, and on the other side, 7 squared would be 49. And in this case, the equation turned out to be linear, could have just as easily turned out to be quadratic. And now I'm going to wind up working on solving for x. So I'm going to subtract 3 from both sides. Okay, that gives me 2x equaling 46. And then I need to get rid of the 2. So since it was multiplying, I divide by 2. So do you see how when we were solving even that linear equation part, we subtracted 3 because we had 3 that had been added, and that undoes each other. Here we have multiply by 2, so we divide by 2 to undo what's been done to x. So we just had to do that in the beginning step to undo the square root. We squared. So it's kind of a very logical process. All right, now this one's going to work just fine, but really, technically, you should check these unless you're sure of that. So what you would do is you would plug in the 23 right back there where the x was in the original problem and just see if you get what you're supposed to get. So right here, you'd put the 23, and then you'd work that out. So you see how that would be 46 plus 3, which would be 49. When you square root that and subtract 4, you are going to get 3. That would be 7 minus 4. So this is the answer. Okay. All right. And I want to look at number 5 next. I'm just doing a few questions on here because we're going to do it in class, but just to give you something in case you missed class or just are trying to review and you forget a little something. So here I have radicals on both sides, but you just got to get it isolated on one side. So we have it already isolated. So we'll square both sides, and that'll undo the square root on both sides. So you wind up with square root of x squared minus 3x, when you square that, you get the x squared minus 3x out from under the radical. Square root of 18 squared would be 18. And this one turned out to be quadratic. So that kind of determines what you do from there. So I'm going to go ahead, let me get back to my blue pen. I like it better. I'm going to go ahead and subtract 18. And then I did that because it was quadratic. So I knew I wanted to get it equal to 0 so I could factor. So now I'm going to factor it into x minus 6, x plus 3. Okay. That's going to give me either x minus 6 is 0 or x plus 3 is 0, which means I think x could either be negative 3 or 6. I'm going to go back to the original problem and I'm going to check them. And I'm going to put a 6 in first everywhere there is an x and see if I get square root of 18. And that would be 36 minus 18, so I would. Okay, so this guy's good. Then I do the same thing, but with a negative 3, and make sure that negative 3 is in parentheses when you replace it. Let's see if we get square root of 18 on that. So that's 9 plus 9. Yep. Okay, so that one checks. So you would put both of those in as your answer. Okay. Now, when you're having to square both sides, that's when you need to be making this mental note. When you square both, the step at which you square both sides, this resulting equation that we're getting here and here, those equations, when you solve those equations, the solution that you get at the end is definitely a solution to those equations, but it may not work in the original where the square root still was. That's why you have to check it. Squaring both sides could introduce an extraneous solution. Just make a mental note. The second you square both sides or raise both sides to the 4th power, make a mental note that you need to check your answers. Okay. All right. Now, when we get to a problem like number 7 or number 8, I'm definitely going to have done number 8 in class. Let me try 7 here. Let's look at 7. So if we do number 7 here, I've got a plus 4 on that side where the radical is. So I'm going to subtract 4 from both sides first. Okay, this problem and number 8 both have an issue people tend to mess up on. You know to isolate the radical, and then you know to square both sides in this case, and the same thing would be true on number 8. Problem comes in on that right-hand side. When you square the p minus 4, make sure you're thinking p minus 4 times itself, and that you FOIL that. Because a lot of people will write p squared minus 16 or p squared plus 16, but it's really p squared minus 8p plus 16. You got a middle term and it does not cancel out. So that right-hand side is p squared minus 8p plus 16. All right, now the left-hand side, we're just going to square something that we had a square root over it. So that's going to become 2p squared minus 5p minus 12 with no radical. All right, let me just bring that down. And then I noticed these squared, so I'm thinking to myself, okay, well, I'm going to solve it like I would a quadratic. So that means I'm going to work on getting a 0. I'm going to work on getting a 0 on the right. So I'm going to go ahead and let me change that to slightly skinnier. Okay, there we go. I'm going to go ahead and subtract the p squared, add the 8p, and subtract the 16. Okay, when I do that, I get p to the second. Oh, not 13. I was going to write 13, but that's a minus 5p. Come on. So that'll be plus 3p minus 28 equals 0. All right, so I have a lot more work to do. Let me see if I can get just a little more space in here. I can get it to do what I want. Yeah, good. Okay, so now I'm going to go ahead and factor. I'll use a 7 and a 4. And these have to factor. If they turn out quadratic, they have to factor at this point because we don't know another technique yet. So when we add 4, we'll get p equals 4. When we subtract 7, we'll get p equals negative 7. We don't actually put both of those into the system yet. We have to wait to see if they would work. So I'm going to do the check above it. So when I put a 4 in, I would get square root of 2 times the 4 squared minus 5 times the 4 minus 12, and that's where the radical ends. Then I'm going to add 4, and I'm going to see if I get 4. Now this 4 was just part of the problem, but that 4 was where p was. All these were where p was. So on the right-hand side, I'm going to have 2 times 16. So that's 32 minus 54. Nope, I don't know why I said that. 32 minus 20. So that would be 12 minus 12. Oh, so that turns out to be square root of 0, which would be 0. And then 4 would equal 4. So this one for sure checks. Then you'd go back, and everywhere there was a 4, you need to now put in a negative 7 and see what happens. Okay. And these answers, they could both work, they could both not work, or one might work and the other might not. So here I get square root of 2 times 49. So that would be 2 times 49. That would be 98 plus 35 minus 12. Then I'm going to add 4, and I'm supposed to get a negative 7. I can already tell this isn't going to work because the square root of something should be a positive number. All right, so 98 and 35, that's 120. 133 minus 12 plus the 4. These are all question marks. We don't know. We're trying to see if that would work. 133 minus 12, that would be 121. But you see how I need to take the square root? That would be 11, and this is plus 4, and that would not equal a negative 7. So this guy I have to rule out. Now, I'm not ruling it out because the p turned out to be negative. I'm ruling it out because when I plugged it back in, it didn't make the original problem true. So 4 would be your only answer to number 7. Okay. All right, and then let me make up my own problem that's sort of like number 9, but more like what you might see sometimes. Like if I had, say, the cube root of, x minus 5 equals, say, 2 or negative 2 even, okay? Because it's a cube root, if I were asked to solve that, I would come in and I would raise both sides to the third power. You still would want to isolate the root, which it was, okay? Then, because it's a 3, I'd raise things to the third power. I'd get x minus 5 equals negative 8. I'd add 5 to both sides, and I'd wind up with x equaling negative 3. And that'll be my answer. Cube roots, as long as all my arithmetic was correct. Cube roots, you don't really have to check them. You don't get extraneous solutions when you do cube roots like you do when you get square roots. Okay, so that's the idea that you would use on number 9. You would just get the roots on each side. You would isolate a root on one side and then go from there. Okay, I'll let you finish that one. But with number 10, this one's really a toughie. On question number 10, the problem here is we have 2 radicals and you can't isolate them both. So what you do is you move one of them off of that side. But then it's over there with the 1. Okay. But I added the square root of 2x plus 1 to both sides. I'm now going to square to get rid of this root right here. And I got to square this whole side, which has 2 terms. So don't forget, that's 1 plus the square root of 2x plus 1 times itself. So this one right here is quite a bit more challenging than all the rest. Probably harder than you need to worry about for a test. Okay. Then I'm going to FOIL the right-hand side, and I'm going to get a 1. And then I'm going to get plus square root of 2x plus 1. It's got a 1 in front of it, like 1 times the square root of 2x plus 1. and then another 1 times the square root of 2x plus 1. And then when I do the square root of 2x plus 1 times itself, okay, that's going to be the square root of 2x plus 1 squared. That's going to be this times itself. Okay. On that right-hand side, I'm going to have 1 plus 1, 2 of these plus 2x plus 1 without a radical on it. Okay, let me bring down that 3x plus 4. All right, so what makes this problem so much harder is we still have a radical left. So to do one like this, what we're now going to do is work on getting this by itself. Okay. So I like to go ahead and simplify that right-hand side. There's a 1 here and a 1 there. So I know I have 2 square root of 2x plus 1 plus a 2x plus 2. Okay. I'm going to move the 2x and this 2 out of the way. So that's going to give me an x plus 2. And that's going to give me 2 times 2x plus 1. Okay. Now, sometimes I go ahead and get rid of the 2 that's out in front of the radical, but I don't think I want to, because if I did, I'd wind up getting fractions. I'd have 1/2 x, and I don't want to deal with a 1/2 x. So I'm just going to leave that 2 there. But at this point, I'm going to have to square again. So again, this problem had 2 radicals, and when you move so that one of them was isolated, this square root of 2x plus 1 wasn't over there by itself. You actually had 2 terms, and so you wound up really having to do this difficult step of foiling something with a radical in it. Then I got to kind of start the process again and square both sides. So don't forget again, this is not x squared plus 4. It's x plus 2 twice. So it's x squared plus 2x and another 2x plus 4. And on the right-hand side, don't forget to square the 2 and square the 2x plus 1. So you're going to wind up getting rid of the radical at that point. Okay, so I still have, oops, hoping that wouldn't move. Okay, let me see if I can bring that back. I got it all messed up now. Shoot. Oh, well, let's just continue from there. Okay. All right. So at that point, I would go ahead and distribute and get an 8x plus 4. Over here, x squared plus 4x plus 4. It's still quadratic, so I'm going to move the 8x and the 4 over to get a 0. Okay. When I do, I have x squared minus 4x on the left. That goes away, and this would be equal to 0. Now, this sometimes gets people because it has a squared, but you don't unfoil it. It's not 2 sets of parentheses. I'm just going to factor out the common factor, and I get 2 possible answers, either x equals 0 or x equals 4. Okay. All right, so I'm going to go back and bring that, go back and look. Let me find it on my paper. The original problem we had at that point was the square root of 3x plus 4 minus the square root of 2x plus 1 equals 1. So I'm now, for my check, I'm going to plug in 0 one time, see what happens. So if I put a 0 here and here, let's see what we get. We're trying to find out, do we get 1? So that would be square root of 4 minus the square root of 1, which would be 2 minus 1, which would equal 1 like it's supposed to. So 0 works. Okay. Then I'm going to go back, and right there where the 0 is, I'm going to be putting in 4 and see what happens when I plug in a 4. Put a 4 here and a 4 there. Okay. Then I'm going to have square root of 12 plus 4, which is 16, minus square root of 8 plus 1, which is 9. That is 4 minus 3, which equals 1 as well. So both of them actually work here, and you would put in both of those answers. Okay. All right, so I want to do one more problem. I'd like to keep these kind of short, so I'm just doing a few selected problems to get you going on it, enough to where you can get in there and do your homework. All right, so I think I just had this one application problem. All right, so let's just get it set up to start with. So here's a formula that can be used. The X is the length of the skid marks. The S is the speed of the car in miles per hour. So on A, we want the speed of the car. So we won't finish this one. We'll just set it up. So that means you'd put the 324 in for X and just work that out. But on B, I'm asking how long would you expect the skid marks to be if the car had been traveling at the speed limit of 60 miles per hour. So this time the 60 goes in for S. And our job is to find the X, which is under a radical. So let's finish that part of it. I would divide by 4 to get the radical by itself. So I'd wind up with the square root of X equaling 15. And so then I could square both sides, and I'd wind up with X equaling 15 squared. I think that's 225. Okay. And the units are feet. So we would expect the skid marks to be 225 feet. All right, so I just wanted to do selected problems off of the 8.6 sheet because I know we're a little bit short on time, and we have a test coming up on Wednesday in my Monday-Wednesday class and on Thursday in my Tuesday-Thursday class. So this might give you enough to be able to get in there and work those problems. And we'll do the rest of the problems in class. So let me go ahead and get this posted.